Okay, let's open our project again. I added some graphics already into this project, so let me explain how it's working. Because in previous one I just added S meter, now I added some more to looks more better. So now we have a tuning knob, we have display, knob is working. It's volume regulators, but it doesn't work yet. I didn't write the codes for that. We moved all the buttons we don't use on the right side. Later we will delete it. So let's see. Let's connect. So we can see frequency. We can see how read is working. Split option, VFO-A, VFO-B. I did some mistake, need to replace VFO-B and VFO-A by places. We will do it together. So when we click it, green light. Now we can change VFO. Regulators are working, but there is no code, so when we regulate it, nothing happens. It's only reading data. Now mode switch doesn't work yet, no code inside. In next video I already will add the code, so our graphics will be almost completely finished. Also we need to add functions to switch and functions to check to switch between signal, power, SWR and other parameters. So let me show you what I did. First of all, I removed everything from the timer. So we don't want to use timer anymore to display the data, because it's slow. We're reading a lot of parameters, and in case our main user interface is drawing a lot of pictures, timer working very slow. I did system calls. It's like in professional programs done. So here when we read in VFO or any other data, any other parameters, we send in Windows message to update our data for display. Of course, we can add an option to update it only if data change it. It will be much better, but right now let's keep it like this, because as I said, we started from the simple way and we go into more better ways, step by step. So now let's use a system call for every cycle of our main thread. Later we will add option to update it only when data change it. Just for that option we will need to add some more variables to keep the old data to compare with current one. But if you want, you can do it by yourself. It's very easy. You can create a variable called previous, like VFO previous VFO, and when you read VFO function, You can compare it, VFO data with previous VFO data, and if it's equal, then skip post message. If it's not equal, post message, and then make previous VFO equal to current VFO. It's very easy. It just will take some more time to add code. It's our graphics. It's our CIV commands files. I added some more functions. Every time I add more and more functions to make complete CPP file with all possible ICOM CIV commands. So you can use it in any project you want. Just add this CPP file and use the functions. It's our graphics file. So I added some images. I added image and put 2 paint boxes over the image. On the image will be background panel, and 2 paint boxes we will be drawing parameters we are reading. This one is for VFO update, this one for S meter. Why I'm using paint boxes? Because it's little bit faster and little bit better for code writing. So here we add function show image panel. In case we not updated, it's always displayed. We do it only once, and here our resource file where all images are located. It's paint boxes. For paint boxes is little bit different. For paint box, in case it's always updated, we need to update it every time. It's so there is a meter init. It's for S meter. Then we update, but basically we may not update it. Here it will be updated automatically. Same with the bars for volume regulation, power. So we can init it only once. All other will be done in the paint box event called onPaint. Here we just call show image to display pictures of the read, split, and switch VFO A, VFO B. There is our knobs. We load main knob, and then we add small circle by loading bitmap with transparent color. And there is VFO init function, our main display. So let me show you these functions in H file. VFO init, VFO update, and VFO destroy. When we close the program, we need to destroy all these functions. In other case, when we close the program while it's drawing, it may give you error. It looks not very good. So on form close, after close all the handles, we also destroy all the paint box images we did. So when we disconnect, when we close the program, we do radio connected files. Then we wait 200 milliseconds, thread is finished. Then we close when we close the handle written for. After that we close handle COM port, and then we destroy our paint boxes. Now program can be closed safe. There is a little bit garbage functions in the graphics CPP. We will remove it later. When we finish graphics, we will remove it to not take space. So VFO, update VFO is a very large function. There is a lot of different pictures, because every digit I did like a picture, because there is no font with these digits like ICOM transceiver using. So I had to back up it from the radio and move it into the program. So in VFO init we need to load every picture. The words read VFO-A, VFO-B is also as a picture. It's a small digits for read and VFO-B. Then we also need to create brush to make a frame, make a blue frame around the LCD. It will be looks better than without frame. In VFO update we have we need to call few variables. And here we just the first step we draw in frame, make rectangle, and then fill frame rectangle. After that we need to display large digits. It's starting from the X position 12. There is HDC, char A, it's VFO data, char B is read data, char D is read frequency. So when we read VFO or when we read data, we need to call VFO update function. Also there is added VFO-B, it's char F1 or char F2, I not remember now. And integer F3, it's split status. If 0 if split is off, if 1 is split is on. So here we draw in large pictures, here we draw in read pictures. And the last is split frequency. So it's starting from X position 12. We check in which from on VF4 data we get in VF string with the frequency, and we check in every symbol and display the digit when which is equal to received one. There is a display dot. And after every step we add the distance between the symbols. If symbol is dot, we add 13 pixels. If symbol is digit, we add 46 pixels. In read small pictures, so there is distance between symbol is less. This one is convert read data from chart to integer, and if read is enabled, we display it. If it's disabled, we not display it. It's for split frequency starting from the 70 pixels, and integer f3 is split enabled or disabled. If it's enabled, we display VF4A or VF4B depending on which VF4 we are using. Here, as I said, I'm mistaken, so let's replace it. So we need to exchange the pictures VF4A and VF4B between each others. It's VF4 destroy, we just delete all the objects we loaded. This one is system call. It's called system call. So when we call this when we do in system call, it runs the function somewhere in the main program. Let me find the function for VF4 update. This one, but we should create it manually. It's not like you can select any component on the top. We need to write these words manually. Void fast call form to double colon, and here in this function we just invalidate paint box 5 repainting. It's our paint box 5 paint event. Here we when we call paint box 5 invalidate, it's clear the paint box space, and then it call VF4 update function. Here we using paint box 5 as a handle, VFO data, read frequency, VFO data, read data, split data, and VFO number. In next video we will add one more variable, because we need to make a switch between frequency steps. It's our system calls. In the top of the program we define the system calls. This one system call for VFO update. So we need to create this system call, and we need to create a function WM VFO update. And in the unit 1H we need to define the same system call, WM update VFO. Here there is listed all the system calls we now using. VFO, S meter, update audio frequency, update read status, update split status, and in the end, in the private, we need to declare these functions, because this function is not appear automatically. And after functions we need to create message map. Begin message map, then message handler. In message handler, when we receive WM update VFO, we need to call functions WM update VFO. So it just lists the defines and the functions which should be called. So here we post message from one handle, WM update VFO. When Windows receive it, it calls the function WM update VFO, which is invalidate paint box 5. Same with other paint boxes. Let me show you how the bar is written. There is also bar init, bar update, and bar destroy. But this function is a little bit smaller. For bar init we need just two pictures. Picture of the bar and picture of the small reel, which is going up and down. One picture is a bar, and second is a small reel. The gradient color inside we are painting inside the bar update function. Show bar we don't need it, we will delete it later. This one is bar update. So here we need to define the size, the distance the bar is moving from tree to top. And here we define rectangle, which we're going to paint into the gradient color. Here we display the bar. This function is painting bar into the blue gradient color. We paint it full from bottom to top. This one is function to paint into the red color, but here we painting it only from the real position to the bottom. and then we just draw the pictures. So let's remove it, we don't need it. Basically we need to only bar init. All bar updates we can remove. I will remove it later. We don't need it, it just take a space. Why we init only on paint box 2? Because in any case it loading the same pictures and will be painting or all paint boxes the same same images. Now here for regulator we need to use events like mouse down, mouse up and mouse move. So it's paint box 2 invalidate when we getting any changes. Paint box 3, paint box 5, it's all of them regulators. Now on mouse down we need to select the which part of the picture when we press to be activated. So we need to press only rectangle with the reel. So it's coordinates of the rectangle on the on paint object. You can print screen and then load this image into the image editor to see from which pixel it start. And then next is AF regulator property we making true. It's a logic variable, so we allow to move the reel. And if our main thread is active, we need to stop it. And on mouse up we just release everything. And here our audio frequency regulator. If AF regulator is true, then AF variable integer AF position AF pos is equal Y, vertical coordinate. So we need to protect ourselves from the errors if we send wrong command into the radio. So if AF pos is less than 3, AF pos is 3. If it's more than 122, then it's equal 122. Then let's check direction. If AF pos more than AF previous pos, then direction is true, top. Else is direction is false, so it's going down. Then we call write AF bar function. This function is in our ICOM radio info CPP file. it's using a handle port, integer A, it's radio ID, char B is our AF volume, integer C is coordinates y, and bool D is direction, up and down. There is a few two write function. Write AF function is only change volume by one position, so it's read current volume at 1 and write it back, and volume bar is change it on the current position we enter. So we call radio ID AF volume. Coordinates we need to recalculate it because we coordinates is counting from the top, but we need to work regulator from the bottom, so we need 255, it's a maximum volume, minus audio frequency position multiplied to 2. Why multiply? Because there is volume bar is twice less, it's only 128 pixels. And after that we call Windows message, post message form 1 handle WM update audio frequency. I also add bar update on the bottom, but we don't need it, we just need to remove last two lines. Bar update and paint box invalidate, we don't need it. In any case, it will be called by this Windows message. So let's connect the radio. Now all the regulators are show the value. Audio frequency is working. All other is not yet. All other working only for reading. So there is images. We are loading red button by default, all of them. This panel is image 10. These images are for knobs. So let's connect our knob, external one. Green light is on, read is on. So let's rotate our external knob. You see, knob on the picture is always also rotating. Same with read one. This now we switch the modes on the knob. Later we will remove that picture and we will draw somewhere else to indicate that knob is connected and which mode is it. Okay, there is a mistaken. Instead of 0 I put 2. So let's check if it's working. Okay, now V4B. Let's switch it. Yes, now V4AB working correct. Okay, so in next video we will finish with the graphic. So all of them will be working. We will remove all the garbage pictures because we don't need anymore the buttons to read, to change frequency, to switch read on and off, to change read. We don't need it because we already have a better option to display it. And after that, before we start with internet connection, we will make sound, so we can also connect sound from our radio to computer, and then we can start with internet. We finished for today.